In this lecture, we're going to talk about quadratic equations. First, let's look at the definition of a quadratic equation. A quadratic equation is one of the form ax squared plus bx plus c equals 0, where a, b, and c are all real numbers. We're going to look at several different methods for solving quadratic equations. First, we'll start with solving quadratics by factoring. To solve a quadratic equation by factoring, the first thing that you want to do after you have it in standard form, that's the form that was on the previous slide, you want to factor the quadratic expression. After factoring the quadratic expression, the next thing you'll want to do is set each factor equal to 0. This is using the zero product property. Then you'll solve the resulting equations from each of those factors, and finally check your solution. Make sure that what you got is correct. Here's our first example of solving by factoring. We have the quadratic equation 3x squared plus 5x plus 2 is equal to 0. We want to solve by factoring. Remember, to factor out a quadratic expression, the first thing you want to do is multiply the first and third term together. So AC is equal to 6. Next, we want to list the factors of 6 and find the one that adds together to give us our middle term of 5. So some of the factors of 6 are 1 and 6, negative 1 and negative 6, 2 and 3, and negative 2 and negative 3. And looking at those factors, we can see that 2 and 3 are the pair that add together to give us the middle term of 5. So we want to rewrite our quadratic equation using these factors of 2 and 3. Our quadratic equation can be rewritten as 3x squared plus 3x plus 2x plus 2 equals 0. Now we'll factor that by grouping. We group the first two terms together, and we group the second two terms together, and try to find a common factor to pull out from each group. We can factor a 3x out from the first group, giving us 3x times x plus 1, and we can factor a 2 out of the second group, giving us 2 times x plus 1. We have a common term of x plus 1 in both groups, which can be factored out, giving us 3x plus 2 times x plus 1 is equal to 0. We set each of those factors equal to 0 using the zero product property, so 3x plus 2 equals 0, or x plus 1 equals 0, and then we solve for x on each of these equations. And that'll lead us to x equals negative 2/3, or x equals negative 1. The final step would be to plug these in to our original equation to check and make sure that they are indeed solutions. Here's another example. V squared plus 7v plus 6 equals 0. Take a few minutes and see if you can solve this by factoring. So we start by factoring out the quadratic expression. This factors out to be v plus 1 times v plus 6. Next, we set each factor equal to 0, so v plus 1 equals 0, or v plus 6 equals 0. And finally, we solve each equation above for 0, so v would equal negative 1, or v would equal negative 6. Another method for solving certain quadratic equations is the square root method. If x squared is equal to p, and p is a positive number greater than 0, then we know that x is equal to plus or minus the square root of p. Let's do an example where we use the square root method. We're given that x squared equals 36, and we want to solve for x. So if we know that x squared equals 36, we can take the square root of both sides. When we take the square root of x squared and the square root of 36, we need to remember that the square root of 36 could be positive or negative, so we have x equals plus or minus root 36. Finally, we can evaluate the square root of 36 is 6, so x is equal to plus or minus 6. Here's another example where we'll use the square root method. X plus 2 quantity squared is equal to 1. The first thing that we'll do to get rid of the square on the left-hand side is take the square root of both sides. And so we wind up with x plus 2 equals plus or minus 1. From this point, we need to split it up into two problems. One problem where it's equal to positive 1, and one where it equals negative 1. So x plus 2 equals 1, and x plus 2 equals negative 1. We'll start by solving x plus 2 equals 1. We subtract 2 from both sides of the equation, and we get x equals negative 1. Next, we solve x plus 2 equals negative 1 by subtracting 2 from both sides of the equation, and we get x equals negative 3. Next, we'll talk about completing the square. So, to complete the square, we start with an expression of the form x squared plus mx. Those are the first two terms of a quadratic expression. To complete the square, we're going to take the coefficient of the x term, m, divide it by 2, and square it, and we'll add that to what we previously had. So we would have x squared plus mx plus m over 2 squared. And by definition, the way that this works is that entire expression can be factored out to be x plus m over 2 quantity squared. Let's do an example where we complete the square. We start with x squared plus 4x. The coefficient of our middle term is 4, so that would be the m value. We'll divide 4 by 2 and square it, and add that to our previous expression. So we have x squared plus 4x plus 4 over 2 quantity squared. We can simplify that. 4 divided by 2 is just 2, so we have x squared plus 4x plus 2 squared. And 2 squared is 4, so we have x squared plus 4x plus 4, which can be factored out to be x plus 2 squared. Notice that the number inside the parentheses with the x is the value of m over 2, or 4 over 2 in this case. Here's another example where we'll complete the square. We start with the expression x squared minus 5x. To complete the square, we'll take the coefficient of the middle term, negative 5, divide it by 2, and square it. And we'll add that term to the previous expression. So we have x squared minus 5x plus negative 5 over 2 squared. If we simplify, negative 5 over 2 squared is 25 over 4. So this is x squared minus 5x plus 25 over 4, which can be factored out to give us x minus 5 halves quantity squared. Now, factoring this expression out may be a little bit difficult. Something that you can remember, as we talked about on the previous slide, whenever you complete the square, the factored form will always take the form of x plus whatever m divided by 2 was. So in this example, our m over 2 was negative 5 over 2, and that's why we have minus 5 halves inside the parentheses with the x. So our next method for solving quadratics is to solve quadratics by completing the square. The first step to solving quadratics by completing the square is to move the constant term to the right-hand side of the equation. So if we start with the standard form of a quadratic, ax squared plus bx plus c equals 0, when we move the constant to the right-hand side, we would get ax squared plus bx equals minus c. The next step is to divide by the number a if a is not equal to 1. Completing the square only works if the x squared coefficient is equal to 1. So if your x squared coefficient is anything other than 1, you need to divide by it. This would give us x squared plus mx equals negative c divided by a. Next, we'll actually complete the square by adding m divided by 2 quantity squared. And remember, whatever you add to one side of the equation, you have to add to the other side of the equation to keep things equal. So that would give us x squared plus mx plus m over 2 quantity squared equals negative c over a plus m over 2 quantity squared. Once we've completed the square, the left-hand side should be able to be factored into a perfect square. So we would have x plus m over 2 quantity squared equals negative c over a plus m over 2 squared. And finally, we can solve the equation using the square root method. So take the square root of both sides and then solve for both the positive and negative values of the resulting problem. Here's an example where we'll solve a quadratic by completing the square. X squared minus 6x equals 13. Since the constant is already on the right-hand side, and the coefficient of x squared is already 1, we can skip straight to completing the square. So we take our middle term, or the coefficient of our middle term, negative 6, we divide it by 2 and square it, and then add that term to both sides of the equation. So we have x squared minus 6x plus a negative 6 over 2 squared equals 13 plus a negative 6 over 2 squared. Negative 6 over 2 is a negative 3, and negative 3 squared is 9, so if we simplify this, we get x squared minus 6x plus 9 equals 13 plus 9. We can now factor out the left-hand side and combine the right-hand side. The left-hand side factors to be x minus 3 quantity squared, and the right-hand side, 13 plus 9, gives us 22. Now we can solve this equation by using the square root method. Take the square root of both sides, which will give us x minus 3 equals plus or minus the square root of 22. At this point, we can split it up into two equations. X minus 3 equals positive root 22, or x minus 3 equals negative root 22. We solve both equations by adding 3 to both sides, giving us that x equals 3 plus the square root of 22, or x equals 3 minus the square root of 22. The final method that we're going to talk about in this lecture to solve quadratic equations is using the quadratic formula. The quadratic formula is as follows. For a quadratic equation, ax squared plus bx plus c equals 0, the solutions will be x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Here's a song that can help you to remember the quadratic formula.
The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now you try. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a.
Before we start doing examples using the quadratic formula, let's talk about the discriminant. The quantity b squared minus 4ac is called the discriminant of the quadratic equation, and it tells us about the solutions. If b squared minus 4ac is greater than 0, then we're going to have two distinct real solutions. If b squared minus 4ac equals 0, there will be one repeated real solution, and if b squared minus 4ac is less than 0, that's going to put a negative underneath our square root sign. That tells us there are no real solutions. So let's do an example where we use the quadratic formula. We want to find the real solutions of the following problem. 3x times x plus 2 equals 1. Now before we can use the quadratic formula, we have to put this in standard quadratic form. So let's distribute 3x throughout the parentheses. That gives us 3x squared plus 6x equals 1. Next, we'll want to subtract 1 from both sides of the equation to get it into standard form. That will lead us to the equation 3x squared plus 6x minus 1 is equal to 0. Now that our quadratic equation is in standard form, we can pick our a, our b, and our c and plug them into the quadratic formula. From our quadratic equation, a is 3, b is 2, and c is negative 1. Remember, the quadratic equation takes the form x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we just need to plug in our coefficients, which will give us x equals negative 6 plus or minus the square root of 6 squared minus 4 times 3 times negative 1 all over 2 times 3. So let's go through and start simplifying this. First, I'll simplify the exponents and multiplication. Simplifying the exponents and multiplication, we'll get negative 6 plus or minus the square root of 36 minus negative 12, all divided by 6. If we complete the addition underneath the square root sign, that'll give us negative 6 plus or minus the square root of 48, all divided by 6. The square root of 48 can be rewritten as 4 times the square root of 3, so we'll have negative 6 plus or minus 4 times the square root of 3, all over 6. And finally, we can simplify the fraction by canceling a 2 from each term. This leads us to negative 3 plus or minus 2 times the square root of 3 all over 3. And that will be our set of solutions. So let's try another example. Again, we want to find the real solutions using the quadratic formula for the equation 4t squared plus t plus 1 equals 0. Take a few minutes and see if you can work through this on your own, and when you're ready, continue the lecture. First, we'll identify the coefficients of our quadratic equation. A is equal to 4, B is equal to 1, and C is equal to 1. So these will be the values that we plug into the quadratic formula. That'll give us t equals negative 1 plus or minus the square root of 1 squared minus 4 times 1 all over 2 times 4. If we simplify the exponents and the multiplication, this gives us negative 1 plus or minus the square root of 1 minus 16 all over 8. Finally, if we simplify what's underneath the square root sign, that'll give us t equals negative 1 plus or minus the square root of negative 15 all over 8. But remember, if you have a negative number underneath the square root sign, that will not be a real number. And since the example said to find the real solutions, we can conclude that there are no real solutions because the discriminant is negative.